Hello! In this video, we'll show you how to recover data from RAID 0, RAID 5, and RAID 6 arrays created on a Dell PERC H700 controller in a Dell PowerEdge R710 server. We'll cover three categories of recovery scenarios. The first category involves logical errors, such as accidentally deleting files, formatting a RAID array, or deleting partitions from the disks that make up the array. The second category covers RAID configuration loss, where the array disappears from File Explorer after the RAID configuration is accidentally recreated or reset through the RAID controller's management utility. The third category includes hardware failures, such as a failed RAID controller or motherboard, simultaneous failure of multiple drives, firmware update failures, unsuccessful RAID level migration or array expansion, as well as accidental overwriting of RAID service information. In the practical part of this video, you'll learn how to diagnose the condition of a RAID array, connect the drives directly to a computer while bypassing the RAID controller, and identify the key RAID parameters required for manual reconstruction, including the drive order, stripe size, and offset using specialized recovery software. The recovery methods and software demonstrated in this video are universal and can be used not only on Windows systems, but also on Linux and Mac OS. Dell PERC H700 controller features. The Dell PERC H700 is an enterprise-class hardware RAID controller that supports both SAS and SATA interfaces with data transfer speeds of up to 6 gigabits per second. The controller is equipped with 6 internal ports, and when used together with a SAS expander, supports up to 32 drives. The maximum RAID array capacity can reach 64 terabytes. Depending on the configuration, it includes either 512 megabytes or 1 gigabyte of cache memory. A battery backup unit, BBU, protects the cache contents in the event of a power failure. The controller supports RAID 0, RAID 1, RAID 5, RAID 6, and RAID 10, works with both HDDs and SSDs, installs into a PCI Express X8 slot, and is compatible with Windows Server, Linux, and VMware ESXi. Its key features include hot swappable drive support, background initialization, patrol read, and automatic RAID rebuild. Recovering files from a RAID array. In this part of the video, we'll walk through the recovery process after accidental file deletion or RAID array formatting. Most often, users lose data after accidentally pressing Shift-Delete, emptying the recycle bin, completely formatting a RAID array, or deleting partitions directly from the disks that make up the array. To recover deleted data in these situations, you can use Hetman Partition Recovery. This professional data recovery solution can scan a RAID array, locate lost files, and restore them with maximum accuracy while preserving the original folder structure. You'll find the download link in the description below this video. As an example, we'll recover data from a RAID 0 array consisting of 2 drives connected to a Dell PERC H700 controller running Windows 11. The recovery procedure for RAID 5 and RAID 6 arrays is identical. After launching Hetman Partition Recovery, the program automatically analyzes all connected storage devices and displays the RAID array on the main screen, showing its RAID level, total capacity, and file system. If you only need to recover accidentally deleted files, select Fast Scan. In this mode, the program quickly analyzes the file system metadata and directory structure, detects deleted files, and determines if they can be recovered. Once the scan is complete, you'll see a list of all detected files along with a preview feature that allows you to verify their integrity before recovery. Next, simply select the files you want to restore and click Recovery. The program will save the recovered data to the selected location while preserving the original folder structure and all file attributes. If the RAID array has been formatted or its partitions have been deleted, use Full Scan instead. In this mode, the program performs a deep sector-by-sector scan of the entire RAID array, allowing it to recover the maximum possible amount of data, even if the file system has been partially damaged. This makes it possible to recover all available data that was stored on the array before formatting with the highest possible accuracy. Before starting the recovery process, make sure the destination drive has enough free space to store the recovered data. During a full scan, Hetman Partition Recovery may detect a large number of files, including ones that were deleted long ago. To avoid interrupting the recovery process and to ensure that all recovered data is saved together with the original folder structure, we recommend using a separate external drive or another healthy RAID array with sufficient free capacity. Connecting the drives. Successful data recovery requires the minimum number of healthy drives that originally belonged to the RAID array. The number of available drives directly affects whether the array can be reconstructed and how much data can be recovered. Therefore, before starting the recovery process, it's important to assess the condition of every drive. For RAID 0, all drives are required without exception, since data is evenly distributed across every drive in the form of striped blocks. The loss of even a single drive makes recovery impossible, since RAID 0 contains no redundancy that can be used to reconstruct missing data. For RAID 5, the minimum required number of drives is one less than the total number of drives in the array. This RAID level provides fault tolerance against the failure of any single drive by using distributed parity. Although reconstruction is possible with one missing drive, having the complete set of drives significantly increases the chances of successful recovery and makes automatic RAID reconstruction much easier. For RAID 6, you need at least 2 fewer drives than the total number of drives in the array. Thanks to its dual parity algorithm, RAID 6 can continue operating even if 2 drives fail simultaneously. For this reason, RAID 6 is considered the most fault-tolerant RAID level covered in this video and offers the highest probability of successful data recovery after serious hardware failures. After removing the drives from the server, you can connect them directly to your computer's motherboard using standard SATA cables or an external docking station. To connect SAS drives, you'll need a compatible SAS controller, since standard SATA ports do not support SAS devices. Do not initialize or format the drives, even if the operating system prompts you to do so, as this may overwrite the RAID metadata and significantly reduce the chances of successful data recovery. Before removing the drives from the server, it's also highly recommended to label or record their original order, as this will greatly simplify the RAID reconstruction process later. If it's physically impossible to connect all the drives, you can use an alternative approach by creating disk images of one or more unavailable drives and mounting those images in the program. To do this, launch the program, select the drive you want to create an image of, and click Save Disk. In the window that opens, specify the location where the disk image should be saved. After the image has been created, return to the program's main window and click Mount Disk at the top of the window. In the dialog box that appears, select Raw Disk Images then specify the path to the image file you created. The image will be mounted together with the remaining drives in the RAID array, allowing you to continue the recovery process as usual. Automatic RAID detection. Now let's look at the recovery procedure when the server itself or one of its hardware components, such as the RAID controller or the motherboard, has failed. These types of hardware failures are among the most common reasons for losing access to a RAID array, because the operating system can no longer detect the logical volume. This category also includes physical failure of one or more drives, as well as critical failures during a RAID controller firmware update that result in the loss of the RAID configuration. To recover data in these situations, we recommend using Hetman RAID Recovery. This software is specifically designed to automatically reconstruct damaged RAID arrays and recover data even when the original RAID controller is no longer available. After launching the program, it automatically detects the connected drives as members of a RAID array and reconstructs the array without requiring any Windows RAID management tools. You'll find the download link in the description below this video. As an example, let's recover data from a RAID 5 array consisting of 3 drives. The recovery procedure for RAID 0 and RAID 6 is identical. After launching Hetman RAID Recovery, the program automatically analyzes all connected storage devices, reconstructs the RAID array, and displays it on the main screen, showing the RAID level, total capacity, and file system. To begin searching for data, select the detected RAID array and run Fast Scan. In this mode, the program quickly analyzes the file system metadata and directory structure, detects deleted files, and determines whether they can be recovered. Once the scan is complete, the program displays all recoverable contents of the RAID array. If necessary, use the Preview feature to verify the integrity of the detected files before restoring them. To complete the recovery process, select the files and folders you want to restore, then click Recovery on the toolbar at the top of the main window. In the dialog box that appears, specify a safe location on another healthy storage device and confirm the operation. The program will recover the data while fully preserving the original folder structure and all file attributes. After the copying process is complete, click Finish. Your recovered files will once again be available to use. If the program cannot automatically detect the RAID array's file system, or if Fast Scan does not produce the expected results, switch to Full Scan in Hetman RAID Recovery. Before starting the full scan, you can specify the file systems that were previously used on the RAID array. This allows the program to perform a deeper and more accurate analysis.
Manual RAID reconstruction. If your data was lost during RAID migration, array expansion, deletion of the RAID configuration, or as a result of accidentally overwriting RAID metadata, for example, after initializing a disk, creating new partitions, or installing an operating system on the RAID drives, use the built-in RAID constructor tool included with Hetman RAID Recovery. This tool allows you to manually recreate the original RAID configuration and regain access to your data even after accidental disk initialization or an unsuccessful operating system installation. Let's look at a practical example of recovering a RAID 6 array consisting of 4 drives, where 2 drives have failed simultaneously. Thanks to RAID 6's dual parity protection, the data can still be recovered successfully. However, this requires recreating the original RAID configuration as accurately as possible. The recovery procedure for RAID 0 and RAID 5 arrays is the exact same. To use RAID constructor, you need to know the main RAID parameters that were specified when the array was originally created: RAID level, block order, stripe size, sector size. For the Dell PERC H700 controller, the following default values are used in most configurations: block order, left synchronous, stripe size, 64 kilobytes, sector size, 512 bytes. In addition, this controller supports the following stripe sizes: 8 kilobytes, 16 kilobytes, 32 kilobytes, 64 kilobytes, 128 kilobytes, 256 kilobytes, 1 megabyte, and 1 megabyte. Keep in mind that these values may vary depending on the specific RAID configuration. If necessary, they should be verified or determined manually. In the Available Disks pane, select the drives that belong to the RAID array and move them to the Selected Disks pane while preserving their original order. If one of the drives is physically missing or has failed, use the Add Empty Disk option to insert a virtual placeholder in its place. Maintaining the correct drive order is critically important because an incorrect sequence will make proper RAID reconstruction impossible. After completing the configuration, click Add to add the reconstructed RAID array to the program's main window. If some RAID parameters are unknown, you can determine them by trying the available options provided by the program. While configuring the array, pay close attention to the preview displayed in the reconstructed RAID window. If all parameters have been entered correctly, the program will detect the partitions, identify the correct file system, and display a readable folder structure. This is the primary indication that the RAID configuration has been reconstructed correctly and that the data is ready for analysis. You can also use the Detect Automatically feature. In this mode, the program automatically tests different combinations of RAID parameters, including drive order, stripe size, and offset, that could potentially match the original RAID configuration. This makes it possible to determine the correct RAID parameters even when no information about the original configuration is available. Keep in mind that automatic detection usually takes longer than manually entering the RAID parameters. However, it becomes indispensable when all information about the RAID configuration has been lost. Once the reconstructed RAID array appears in the list of available devices, you can proceed with scanning it. If the only issue was damage to the RAID configuration, begin with Fast Scan. The program will analyze the metadata and display the folder structure along with the available files. If necessary, use the Preview feature to verify the contents of the detected files before recovering them. If the results of the quick scan are unsatisfactory or the file system has been severely damaged, run Full Scan. After the scan is complete, select the folders and files you want to recover. Then click Recovery. In the next dialog box, specify the destination where the recovered data should be saved and confirm the operation by clicking Recovery once again. After the recovery process is complete, the program will notify you that the data has been successfully restored.
In this video, we've demonstrated practical methods for recovering data from RAID 0, RAID 5, and RAID 6 arrays created on a Dell PERC H700 controller. If you found this video helpful, please click like and subscribe to the Hetman Software channel so you don't miss our future videos. If you still have any questions, leave them in the comments below the video, and we'll be happy to answer each one. Thank you for watching. We hope your data always remains safe.